Hello everyone. my name is Varadarajan, Assistant Professor, Department of Mechanical Engineering. So today we are going to see the case study video of sectional views in the computer machine drawing subject 19 MEB 302. This is a third semester course subject in mechanical engineering students. So here we are going to see how the sectional view will be useful for the representation of view in the diagram. Okay. So first of all, sectioning view. What is meant by sectioning view? So sectioning, the object is imagined as a cut part by the plane so as to expose its interior. This is imaginary process of cutting the object is called sectioning. So the imaginary plane which cuts the object is called the sectional plane. So that plane it will be known as the cutting plane. So that is the sectioning. Okay, here this is a simple view. It will be shown in the front view and the left side view for the diagram of the certain product. This is the sectioning. Okay, we just want to section. Section means cutting. Okay, that is a simple concept. So here the view which is reveal the interior of the object. Okay, with its visible cut surfaces is called sectional view. So the sectional view, it is also represented by the means of cutting the plane. The plane is known as the sectional plane or cutting plane. It will be seen in the previous slide. So this slide, the view which reveals the interior of the object. When the object it will be cutting in equal portion or whatever the half of the portion or 3/4 of the portions, whatever the portions which can be cutting. So the removed surfaces and what are the remaining surfaces? The remaining surfaces view which is called as the sectional view. So that is this thing. Okay. So in the machine drawing practice, except in the special case, always the sectional plane pass through the one of the axis of the object. So sectional plane it will be also, so when the axis we just want to cut the particular object. So that is the main point of section. Okay. So this drawing it will be represented in the top view, sectional view here like this. So the representation of the sectional plane is conventionally represented by the chain is thickened at the ends and the thin elsewhere with this direction of view normal to the sectional plane indicated by the arrows resting on the thick ends and designed by the capital letters. So it will be the line, that cutting plane line or sectional line in the diagram, computer machine drawing diagram. So the diagram which is represented in these types of line, that line is known as cutting line or sectional line. So it will be there. So that is a way of representation of the sectional plane or cutting plane. Okay. So this hatching portion it will be shown in the figure. The sectional view of the object comprises both section and unsectioned surfaces. So the section lines sometimes are also called as the hatching lines. Okay. So that is the sectional surfaces, hatching lines. So types of hatching lines, inclination of hatching and the spacing between the hatching lines, hatching of large areas and hatching of adjacent spots and hatching of adjacent parallel cut surfaces, dimensioning of the hatched areas. So the inclination of hatching, it will be a simplest form of hatching which will be usefully adequate for the general purposes, involves a drawing of continuous thin parallel line inclined at 45 degree to the outlines. Okay, so other types of hatching lines it will be called as the horizontal and 30 degree, 45 degree. These are the hatching lines inclination. Okay, so the spacing between the hatching lines, the hatching must be done in such a way that the sectioned surfaces does not appear as the outline of the object. So the section surfaces should be in the dark surfaces. So does not appear as the dark, so it will be outlines of the object. When compared to the outline of the object, the sectional line thickness also it will be somewhat lesser than the dark. Okay, thickness it will be very less. So when the large area is to be shown in the section, it is recommended to limit the hatching only to a narrow zone following the contour of the section. So when the larger area is to be shown in the section, it is recommended to limit the hatching only to the narrow zone following the contour of the section. So in this diagram, it will be clearly the larger surface we just want to maintain the hatching. So that's why we just want to using a contour surfaces. Okay, we are used to hatch. So hatching the adjacent parts, it is also represented like this. So in the assembly drawings, when the two adjacent parts are to be shown in section, so the section line should be drawn in the opposite direction. So it will be like this. So the opposite direction in this diagram, it will be represented like this. So one hatching line, it will be in the angle of slanting, it will be a right side. The another one is the left side slanting. The angle also it will be different. So hatching more than two adjacent parts. When more than two adjacent parts are also shown in the section lines are drawn in the same angle, that is the 45 degree, but in the different direction also with varied space between the hatching lines. Okay. So up to till this point, we just want to stop this video lecture. So the next video, we just want to continue the how the section line will be useful for further process. Okay, we will see in the next video. Thank you.